Okay, so last thing we need to talk about is the kinds of motion. So there are four main kinds of motion that we deal with, especially in robotics. So the first one is oscillation. Oscillating means something moves back and forth in an arc. And I'm sure you can think of lots of things that do this. Personally, I always think of windshield wipers because I picture a windshield wiper going up and back and up and back. But swings for a swing set also do this. So do Newton's cradles, the little balls that you pick one, it bonks into the next one. That's an oscillating motion because there is basically a fixed point at some point, and it turns in a semicircle. It doesn't go all the way around. Linear is motion in a straight line that does not repeat. This is an animated GIF, so it looks like it's repeating, but it's not. It's like you took this thing and just pushed it. That is a linear motion. It's just going in one direction, either up, down, forwards, backwards, something along those lines. So it's not repeating. Reciprocating is when you get a repeating motion. So in this case, for every one turn on the red here, I'm getting both an out and a back on this slider that's coming back. So that's a reciprocating motion. The motion usually goes back and forth or up and down, and one input will give you two outputs in a reciprocating system. So you got to remember that one. Rotary is just a standard spin. Wheels, I'm thinking, apparently my brain is stuck on wheels. Knobs, wheels, knobs, anything that turns or spins, that's a rotary motion. So now we are going to take a look and see if we can figure out where our inputs and outputs are on a couple of examples. So I'm going to, apparently I'm not. I'm going to come over here and turn on my pen. There we go. So I've got my pen here. This is the input on this guy. So it's got a handle on it that spins, and the vise up here either moves inward or they both move outward, depending on which direction you turn the handle. So they're either moving towards each other or away from each other. So that would make the kind of input motion rotary, and the kind of output motion would be linear. Because it's not repeating, you have to turn it in the other direction to go the other way. So if you come over here and look at the beaters, you've got the beaters down here at the bottom spin on your mixer. And up here at the top, there's two options you can think about for the input on this one. So the output is definitely rotary. You're probably all able to see that without too much trouble. But the input on this one, it's either just a slide forward, which would be linear. It could be a rocker switch that rocks back and forth in that semicircle. That would be oscillating. Or it could just be a button that you press down, which would also be linear. So I actually think it's a rocker switch. So I consider that oscillating. Yes, you would be fine if you also put linear, because it could just be a slide forward or a push down. Can't really tell from the animation. This is an old-fashioned hand crank. So you hold it here. This is the handle. It spins around. That spinning around turns this, which is where the drill bit would go to drill into things. And you would also be leaning on it here to give it that downward motion. So your input in this one is really rotary because your only real input is the handle that you're turning. But your output is going to be two things. It's going to be linear because you're leaning on it to push it through a material. And it's also going to be rotary because it's also spinning the drill bit head as it goes through the material. This one's tough. So first off, you have to pretend that there is no cord. Wrong. This is a hand motion. So in this case, you would turn this dial here to move the sewing machine needle, the needle itself goes up and down once for every turn. That makes your input pretty obvious. That's a rotary. And your output would be reciprocating because it's going up and down repeatedly. You turn once, you get both the down and the up. So that leads us to our last two examples, which are a little interesting. So if you think about this trash can, if you think about just stomping your foot straight down onto a button, that would be a linear, right? That's not how you open this trash can. You put your heel on the floor and you rotate from your heel, pressing your toes down to press the pedal. That would make the input oscillating. Now for the output, this can lid does not go straight up. That would be linear. It doesn't go straight up. It doesn't spin around. It goes halfway, right, in an arc like that, making the output also oscillating. Okay, bicycle. You're going to argue with me because you're going to think that this is different than it is. So first off, the input is pretty obvious, right? You got the pedals and they turn around. And so I would say that the input of the bike is definitely rotary. But the output is where we're going to disagree, because you're going to say the output is rotary because the wheels turn. And I'm like, oh, great. But is that the goal of the bicycle? So the bicycle goes around in a circle? No. The bicycle goes forward or back if you pedal backwards, I suppose. Actually, it doesn't go backwards when you pedal backwards. Anyway, for the most part, bicycles roll forward. So my argument is that the output on this one is linear. Now, you can make the argument that it is rotary because the output is the wheel turning around, but the whole bike goes in a straight line. So I like to think of this as a linear motion because I'm thinking of the whole thing all together. So that should wrap up all of our observing mechanisms, and make sure you've got everything in your notebook and in your notes that's going to help you for the mastery check.